79. If you've missed any of the days this week, there are videos for every day. Tuesday's video got cut short a tiny bit, so the very beginning, the day one of doing all of these, which was Tuesday. But every other day, I've had one. Fingers crossed that this continues. This lets me get through the whole thing. Otherwise, I'll have to post one that's kind of cut short by a little bit too. I've been trying all day. It's just something has happened every period. Okay, so let's go ahead and start. The height of the tide in feet on an intercoastal waterway is modeled by function h. Based on the model, which of the following is true? So looking at our possibilities, it's minimums and maximums. I'm sure you can guess, clear your RAM. You're going to have to type that in your calculator and look at the graph. So I want to share something that I make a mistake on all the time, because I will be looking at this while I'm typing and not double checking that I'm typing it right. And something I have done a couple times today is I'm not looking at my screen, and I'll see a parentheses, and I'll type a parentheses, even though my calculator already put the parentheses there. That will change the graph, potentially. And it does on this one. And luckily, I knew what the graph was supposed to look like, so I knew that I had typed it in wrong. But you can imagine, like on an AP test, where you're not talking to other people and comparing or looking at what I'm doing, you wouldn't know that you did it wrong. So you just want to be really careful typing it in and making sure that you don't make any mistakes. I'm going to go ahead and change my window right away as well, from 0 to 12. And let's see what we have. So we're zoomed in on this piece of a cosine graph, and I think you guys would agree with me that we have a min in this interval, no max. So even if you didn't know how to find your minimum, we're at a 50-50 shot here. And then we have the minimum button, so second calc. So it's the same place as intersect and max and 0. So minimum is 3. And it puts my cursor on the graph. I want to be, this is not an exact science. Somewhere to the left of the curve, enter. Somewhere to the right of the curve. Just as long as you're to the right of the actual minimum, that's fine. And then it says guess. You say yes, please, and hit enter again. And we would be looking at the y value in this case, because min or max is how high or low you go. So I think you guys would agree it's 3.5. Okay. One of the questions that or concepts that keeps coming up is inverse. Inverse is a big takeaway from this whole year. And when we talk about the inverse, we're talking about x's and y's. And we've had to talk about inverses in a couple different ways. In ordered pairs, like a table of values, if you switch the x and y's, that's the inverse. Same within a table, if you flip the points, that's the inverse. In an equation, you switch the x and y and solve for y. We'll do that in number 81. And in this one, we want to know the domain of the inverse of this graph. So we have a graph. We want to know the domain of its inverse. So remember, domain and range are x's and y's as well. So if we flip the domain and range on this, we would get the domain and range of this. In other words, the range of this graph will be the domain of its inverse. It's just they trade places. And the range here is from 3 to 9 inclusive. So the range on here would be the domain on here. Okay. Switch x and y. Now, this question is one of two that prompted a lot of good conversations today. I showed my way of doing it, and then I had a lot of hands go up and say, I did it this way, I did it this way. I'm interested if you guys have other ways, and I'll share those with you. I'm going to show you really like the steps involved algebraically, which also helps us kind of understand a whole bunch of different concepts, so just bear with me for a second. The graph up here is of a log function. Which equation represents the inverse of this equation? Well, first I need the equation of this guy, so I can switch the x and y and find the equation of its inverse, and that's what we're going to do. So going back to what they gave me, they're telling me it's a log, and if I look at all my choices, there's an e in all of them. That's telling me that it's a specific type of log, which is a natural log. Natural logs always have the e's as their base, so seeing those e's out there is telling me that. Okay, so now I'm saying this is a graph of natural log, and it's also, you can see that ln right there too, that's a hint. I didn't even notice that before. So here we have a graph, but it looks like it's been translated. It's been moved. One thing you can do, if you're not familiar, which it's normal if you're not, about what the parent function of this is a calculator problem. So clear your RAM because you messed with your Windows probably. And if I just type in natural log x, I want to see what it looks like. Okay, makes sense that the natural log looks like this. Let me look at my table of values. All right, the parent function has a point at 1, 0. So this is not the parent function. This is a translated version. It has moved. All the points have moved, okay? So let's go from this point to this point and see how far we moved. We're clearly moving to the right and up. How many points? We are going right 2, up 3. From this point to this point, right 2, up 3, okay? So a lot of prior knowledge having to be accessed here, including when I plug the 2 and the 3 into the transform graph, it would look like this. Y equals natural log of x minus, right? When we go to the right, it's a minus, and then up 3. That is now the equation of this graph. To find its inverse, we switch x and y and solve for y. So we want to get y by itself. And we're going to do that in a minute, but what we have to do first is get the word log and its argument, what's in the parentheses is called the argument, by itself. So I need to move this 3 to the other side. And then just like we did yesterday, we had a problem where we had a natural log in it, we had to solve it. You rewrite it in its other form, base e to the power of something. And you can see all of these examples have an e to the power of something. The base of all natural logs is e, so that's where they're getting at. E to the x minus 2 equals y, or x minus 3 equals y minus 2. So e to the x minus 3 equals y minus 2. Add 2 to both sides, and we would get e to the x minus 3 plus 2. One student said they typed all 4 of these in their calculator until they found one that matched this. And they could use the table of values to kind of do that. Did anybody do a different method? When you look at the asymptote, you can 100%, we have an asymptote at x equals positive 2. You 100%, and there's only one that has that vertical asymptote at 2. You would have to have that access, that prior knowledge that you get a VA from this number right here. If you know that, sure. I mean, remember, there's no work that has to be shown, okay? So however you're able to get to the right answer, besides cheating, of course, is perfectly fine. I honestly don't come up with every possibility. I mean, sometimes I do, but I learn a lot from my students. Like when I taught the unit circle to you and how all the little memorization tricks, I always get people saying, oh, I see this and I see that, and I welcome all of that because you never know what somebody else will grab onto as helping them. So there's probably more ways than what I'm thinking of right now, but find your way. I showed you like the algebraic way, but get the right answer is the bottom line, okay? 82 was another problem I hadn't taught you yet by the time you got to the mock exam. So you probably guessed on this one, maybe, I don't know. But we just did one of these in the non-calculator packet. So this is really similar. Given an x and a y rectangular coordinate, we need to change it to r and theta using the same formula we've been using, our little Pythagorean theorem, and this formula. So we've seen it a lot. You know you're going to have to know those. And it's totally optional to sketch the graph in its quadrant. This is in quadrant 2 because I go left to up 5 to get to that point. So just knowing it's in quadrant 2 is what matters. It really does matter. Because when we find our theta, it's also going to have to be in quadrant 2. They're going to match. Okay? So I'm just going to square my x and square my y. I'll get r squared equals 29 and r equals the square root of 29. All of our choices had that, so you could have saved some time on that, but I wanted to review it anyway. Here, I would do y over x. And we had a question like this the other day where it was a -1 here, and it was a non-calculator portion because we know what all our tantrics, or know from our tantrics that when we get a -1, it was a denominator of 4, it was in quadrant 2, so we knew theta was 3 pi over 4. Here, obviously, that's not something we memorized. We're going to go to our calculator. And when we go to our calculator, you will be using your inverse button because we're trying to find theta, so you always use your second inverse, also known as arctan. So second tan, 5 divided by -2, and we get -1.190. But that is not our answer. This is not our answer, okay? Here's why. Your calculator is wonderful, but it can only do so much. Your calculator can give you a positive answer or a negative answer. It doesn't know what quadrant you're in. It's going to give you positive or negative. And what this calculator does is if it gives you a positive answer, we're in quadrant 1. If it's a negative answer, it's in quadrant 4. That's all it can do. You have to say, wait a second, my angle is not in quadrant 4, it's in quadrant 2. So what I'm going to do is add pi to get myself in quadrant 2. The same goes for quadrant 1. Let's pretend we had a triangle, like what was given to us was in quadrant 3. I'll just make one up. Left 5, down 2. We would get a positive tan, right? Tan is positive in quadrant 3. Negative, negative, become positive, positive. So if you do this one in your calculator, whatever the problem is, and you try and you put it in your calculator, you're going to only get quadrant 1 tan's value. You have to say, oh, I know I'm in quadrant 3, so I would add pi to put yourself there. So remember, your calculator is going to give you 1 or 4. You have to add pi if you're in 2 or 3. So that gives you A, and you add pi to this. Okay? A-T3. Clear your RAM. We're going to put this one in our calculator, of course. It represents an alien's body temperature. Of course it does. Why wouldn't it? And we want to know what's happening on the graph when 60 minutes. T is 60 minutes. So we're going to graph it. And then when we figure out where 60 is, we're going to determine is the temperature increasing or decreasing and at what rate. Remember, increasing or decreasing on a graph is going up, increasing, down is decreasing. Makes sense. And the rate has to do with concavity. Increasing is concave up, decreasing is concave down, decreasing down, okay? So go ahead, put it in your calculator. I'm going to put 1/20th in its own set of parentheses. So in this case, I did want double parentheses, okay? And I'm going to multiply 1/20th by t plus 12 pi. I can either hit times, or my calculator knows that parentheses next to parentheses means multiplication, okay? So either one would be fine. And close them. Now, I'm going to go to my window and change to 0 and 120, like it says, for my x-axis. And I'm going to, instead of graphing, if you hit graph right now, it's okay if you did. If you hit graph, nothing's going to happen. Okay, you're going to see quadrant 1, it's going to be blank. And that's because, remember, this number, where we usually would see it at the back, is how high or how low you go. So it has an amplitude of 9, but then we take all the points and go up 115. So that's why you won't see anything on your graph. So you want to also change your y-axis. Now, there's a huge range of numbers you can put in here. All of us can do different ones and we get the same. We know for sure we want to be above 115. And this is really unnecessary numbers. I don't need a negative. None of my, well, actually, maybe I don't know that. Let me go up to 100. I didn't even think that maybe I didn't know that. But let me just go up to like 150, 140, 130. I don't know. What you are looking for when you graph here is that you can see above and below all the points. That's what matters, okay? So yours might be skewed a little higher, a little lower. It doesn't matter, okay? So you don't have to spend a lot of time on it. But if I was cutting off where I could see where it went up or at the bottom where it's going down, I would need to widen it some more, okay? But don't make that too difficult of a situation. Now, where is T is 60? That's what I want to know. So we've talked a lot today about all the different places you can go. And there's actually 2 functions on your calculator that are super, super helpful that I don't even know if we've talked about. One of them is the trace button. We've used alpha trace to store stuff, but trace is a great tool. We just haven't really needed to use it that I can think of. If I hit trace, it puts my cursor dead center in my window, which is 60, which is what we happen to want. And it's showing me where 60 is, and it's giving me the ordered pair at the bottom. Let's pretend it said T equals 30. Well, I could move my cursor along this graph to any place that I want, okay? And you can see where you are on the bottom, right? So it did put me at 60, but if it was like a weird decimal or something, there's something else you could do. So what if it said like 57.862 or something like that? There's another really cool function on here in your calc menu. It's called value. So if I go to that and I hit enter, it's letting me put any X value I want. So if I really wanted to know what was happening at some crazy weird decimal, that's what they want to know, what's happening at that time, I could hit enter and it's going to take me to that point. So that's the X value I typed in, and that's the Y value, and that's where it is on the graph. Okay? So that's another maybe helpful. I mean, there's so much on these. Let me go back to 60. Since I changed it, I'm going to go to value, hit 60, and enter, because that's what I want to be. So now, what is happening at 60? What is happening? You might want to even put a, do I want to do that? No, I don't want to do that. Pretend I didn't do that. So what's happening at, sorry, wasting your time. So what is happening at 60 when it finally gets up there? Do you guys think that it is increasing or decreasing there? We're increasing, right? We're on the up slope. So we're increasing, and it's concave what? Concave up or down? Down, so that's decreasing. We're increasing at a decreasing rate. Okay? All right, polynomial. How many inflection points do we have? Inflection points are where we change from increasing to decreasing or decreasing to increasing. In other words, our mins and maxes. So if I clear my RAM and type this in, everyone, they have your cap and gown information up in student services. They want you to go, I don't know. It just says cap and gown. So, you know where student services is? Yeah, if you want to take the pass and go, you can. Let me type this in real quick. I'm going to do this visually. I'm going to look at the graph and see how many mins and maxes I have. It probably won't take too long. Everyone, you can probably be back. It won't take the whole class period. You can leave your stuff. Okay, so this is a cubic. It's got the opposite end behavior. It's got the little squiggle in the middle. We have a max here and a min here. That is 2 points of inflection. And there is a very rough rule of thumb for points of inflection, which is the degree minus 1. So you'll probably be back is what I'm saying. I leave your stuff here. You can just bring it back. It's a degree 3 minus 1, so it's 2. But there's exceptions to that rule, so I wouldn't live by it. Like x to the third power, the parent function of a cubic, when you graph it, it looks something like this. And that would only have one inflection point of inflection, okay? So, you know, if it's got a lot of stuff going on in it, you could probably just use that rule of your n minus 1. But the simpler it is, you could be less, okay? All right, 3 more. These last 3 questions are super duper wonderful questions. I really, really like them because I think they're very representative of questions we could see on the AP exam. Here's why I like this one. They forced us, teachers, to teach semi-log plots to you. It was at the end of Unit 2. We did it for like 1 day one little concept moving on, and it's just a different way of scaling your X and Y axis. We know semi-log plots will not be in any of your FRQs, so we could see it in your multiple choice, and I think we will since they really talked to us about teaching that, because it just didn't fit. We felt like as teachers it didn't really fit with what we were teaching. Thought it was just strange. So they made a big deal about, yes, we want it in the curriculum, so we think there's going to be a question. And this is a great example of what we would see. So we have a table of values, and it wants to know which of the following graphs could represent this data in a semi-log plot where the vertical y-axis is logarithmically scaled. So semi-log means that one of the axes, usually the y-axis, is logarithmically scaled. And what that means is your y's are counted by base 10s. So 10 to the 0, 10 to the first, 10 to the second, and so on. So let's look at that first. Let's look at all these y-axes and determine what's going on with them. Xavier, let me know when you're ready for the next part. A is just whatever, who knows? I think it's going by tenths. Yeah, 0.1, 0.2, 0.3. So not that one. And not this one either. This one's counting by tenths, 10, 20, 30, 40, 50. Although the points in the graph match these points. So you want to be careful not to just look at that. So these points are these points, but the scale is wrong. Now, let's look at these two. These are both correct y-axes, okay? This is 10 to the 0. 10 to the 0 is 1, and then 10 to the first is 10, okay? This is 10 to the 0, 10 to the first, 10 to the second, and so on. So these are both semi-log plots. They both have vertical axes that are logarithmically scaled. So that's taken care of. There must be a reason they gave us that data. And yes, you can differentiate between B and C according to what the points are. If you look at this graph, our first point, which is 1, doesn't even make it up to 2. This graph only goes up to 10. So none of our points are on that graph, right? This is 128. So it eliminates this one. And if you check these points, they do match what's in the table. Okay. Okay, 86. Another great question. We talked a little bit about regressions the last few days and residuals, and I said we'd review it again with another question. Here's that question. So let's make sure we understand these. This is a table of values, okay? And an exponential regression is used to model these data. So if someone has gone in their calculator, and we're going to do the same thing, put it in recognize the screen? Oh, I forgot. You are watching. Wow. This Sunday's like, I'm going. I recognize the screen. You recognize that student by his screen? Okay. So anyway, somebody took this data, and we're going to do it too. Put it in there. They got a an exponential regression. They found the residual and all this stuff. Okay, let me explain this to you in English. This is your actual data, and that goes for any time we're given a table of values. That's actual real data, okay? When we go into our calculator, that is the predicted, also known as the model, okay? What this question is asking us to do is find G of 5. G of 5 is what? And they mean in this table. So 1, 3, 4, they're asking, what is this value right here? Well, we're going to use, they gave us a residual amount, okay? We're going to put this in our calculator, and we're going to find a predicted amount using our table, and then I'll tell you what we're going to do with that, okay? So let's start by clearing RAM. And remember where we put this data, it is under Stat. Enter. List 1 is your X's. Go ahead. Always hit Enter after your last data point. Then we go to stat, over to calc, and we want to find the exponential regression. It tells us what they want us to model it after. So it's 0 is where you're going to go. And just put your calculator to the side or whatever. 5, I'll put choice right there, and then have a quick one. Okay, so I'm going to go to 0, which is exponential regression. Enter, enter, alpha trace, enter, enter, enter. And if we needed the function, if we needed to write it in that form, there's our A, there's our B. We don't. We want to see the table and go to 5. So our predicted amount in the model is 1.49. That's not the answer, and look, they even put it in there. It's not the answer to the question. They're asking what is G of 5, what we're missing in our table. So there's a formula we learned, which is that the residual equals the actual minus the predicted. This is on your formula sheet, and it's been since like September, since we worked with these. But if you go to your formula sheet that I've been asking you to keep, it's on there. And one thing to help you remember it is actual, predicted is alphabetical order. So you can kind of remember which one goes first, which one goes second. And this is just simple algebra, guys.